Hi everyone, welcome to my presentation. This is an introduction to Rust microbenchmarks using Criterion. I also want to answer the question, should you use toOwned or toString? My name is Michael Mullen and let's get into it. So the agenda for today is I want to talk to you about the problem statement of where I got the idea to create this video. I want to do some live coding with Criterion to do some benchmarking. And then I want to talk about what idiomatic means. So the problem statement. I see a lot of other developers use reference string, reference stir toOwned, but I use reference stir toString. Am I a bad Rustacean? Why do other Rustaceans use toOwned? It is generally believed that the performance is better, and there's a few articles that you can find with a quick Google search that will prove this to you with some benchmarking results. But these articles are 7+ years old, and the question should be re-asked, is it still true that toOwned is faster than toString? So let's measure it. Let's use the Criterion crate to do some microbenchmarking. And what we're going to do in this test is take an array of UTF-8 bytes, have a reference of those bytes as a reference stir, and then turn that ref stir into a string. So let's get to the code. So we're going to create ourselves a program here, and we're going to call that program cargo new lib which2, and we'll get into the which2 here, and we'll check out the cargo.toml, and we will check out the source librs, and then we can do a quick cargo test to make sure that we have something up and running. Okay, so what do we want to do here? What we want is we want to create ourselves a little application that I spoke about before that will, actually, I'm going to get out of NeoVide and switch to NeoVim because I can more easily change the size of the font. So let's take a look at the source lib. So in the source lib, what we want to do is we want to grab ourselves a struct of raw data. And in that raw data, we will just have a vec of U8s, because that's the lowest level implementation of either a reference stir or a owned string. And then we want to import that raw data and have a pub func of new, and that new will take a symbol, which will be a character, and it will take a len, which will be a usize, and it will return a self. And what will happen in here is that we will create ourselves that vector. And then we will populate it with some data here. And UTF-8 can be, a UTF-8 character can be of size 4 bytes. So that's why I'm allocating a byte slice of 4 in size here. And then we want to symbol.encode UTF-8 into that byte slice. And then we want to populate our vector with the data that we have. Okay, and then we want to return a raw data where the data is that vector that we just created. And we also want to have a method here that will make ourselves a ref stir from our data. So pub function to stir, and it will take a self, and it will return a stir, a ref stir. And because we know that the data is good, because we populated it, we can use an unsafe function here called std stir from UTF-8 unchecked self.data, and that will be what is returned. If we don't like this unsafe code, we can use std stir from UTF-8 of that self data too, and it doesn't really matter here. So because it doesn't really matter, I'm actually going to pick the safe option. The difference here is that unchecked isn't going to check that each byte in the vector here is a proper UTF-8 character or belongs to a proper UTF-8 character, while the safe function will check that it belongs to the proper UTF-8. And of course, we need to unwrap this. And in fact, okay. So we've got ourselves a function here. We've got ourselves some basic stuff. Let's make some tests for it. And in this test, we need to use super. And first of all, we want to test regular. And in this test regular, we want to just check that if we enter a regular character, a character like an ASCII character, that it works properly. So let's create ourselves a let ch equal a. Let len equal 16. And let raw equal the raw data new of ch and len. And now we get our reference to string here. We'll call that s, and we'll say raw.toStir. And now assert equals s is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. And let's give this, first of all, let's just give the thing a compile. So it doesn't like mod tests because I have made a syntactic error. I didn't close my impl block. All right, it compiles, and let's do a cargo test, and it tests correctly. Now let's write another test to test for longer UTF-8 characters. And now we're going to let ch equal a UTF-8 character. All right, that'll give us the character here. I guess my terminal doesn't properly show that. Save this. Let me save this, and we will try and see it inside of Neovide, and it should show. Yeah, there, that's the character. Okay, and now let len, and I don't want to copy paste that 16 times, so let's just do it as 4. Let raw, just copy paste this. All right, and now let's do the assert equals that s is equal to a string of that character. All right, and give that a cargo test. Oops. And it is working properly. All right, so now let's get into our benchmarking stuff. So our benchmarking stuff means we're going to be using Criterion. So first we need to install a cargo plugin for Criterion. And the way that you do that is simply cargo install cargo Criterion. And because I want to make sure I'm going to get the latest version, I'm going to do a -- force here. And while that's happening, let's open up the cargo.toml file and set our dev dependencies to get Criterion. And we'll use version 3. And we will also say that our benchmarking program is going to be called which2, and there will be no harness. And now we've got Criterion installed, we need to make a directory called benches. And this is a hard requirement for using Criterion. So we're going to make dir benches, and we will touch benches, and we'll call this which to use.rs. And we can open up that thing here and start importing the things that we want. And we will want to use Criterion and we will eventually use the black box, and I'll talk about that in a bit, Criterion group, Criterion main, and capitalized Criterion. And let's make a quick little function here to just test that it compiles properly. And we'll call this test normal 16, and I'll get into why I'm calling it that in a moment, but it will do nothing. And then our Criterion stuff to give Criterion a main, what we do is Criterion group macro, and we'll call that benches. And then Criterion main will run those benches. And the benches will include test normal 16. Okay. And let's get out of our cargo toml and give this a cargo Criterion. I'll zoom in this window. And in fact, I shouldn't be using that window. I should use this window because you can see it and my face isn't covering it up. Failed to parse manifest. So I have made a mistake in my cargo.toml. I did not properly set this up. So a test function needs to take a mutable reference to a criterion. There we go, and it compiles up. Let's not worry about the warnings right now because we're about to populate it with some stuff. Okay, so let's set our test up here. So let ch equal a, let len equal 16. So that's why I called it test normal 16. And let our raw equal raw data new ch len. And we will compile this up and notice that there is another error. That error is it doesn't know what the raw data is. So we need to use which to, that's the name of our crate, raw data. And our raw data is actually a private structure. So make it pub, give it another try here, and good. We're compiling up. Ignore the warnings. We're about to fix them up. So the next step is to get ourselves the string, the reference str, and that would be raw dot to str. And now we can start doing our criterion stuff, our benchmarking stuff. So what we're going to create here is a group from the criterion C, and it's going to be a benchmark group, and we're going to give it a name of normal 16. And now what we want to do is do a g.bench function. And this will have the name of toString because we are going to benchmark and this is where we will use a black box. And the black box means that things inside of the black box should not be optimized by the compiler away. Such as, say, you're creating a string, but you're never using the string. The compiler might get it in its head to go, well, you're creating this thing that you never use. Let's just not create it. So we're going to stop that from happening by using the criterion black box. And we're going to s dot to string inside of this black box. And then we will close up our benchmarking function. We will then do a g.finish. And let's give that a compile up. Oh, it's not called G, it's called a group. And you can see in the lower right-hand corner, it's doing a quick benchmark. Great, we've got some results for our 16 byte long 16 bytes into a string. And it takes around 11 nanoseconds. But of course, we want to compare this against toOwned. So let's do a group.bench function, and we'll call this toOwned. And it will take a b, the benchmarker, b.iter, and we will use the black box again, and inside of the black box we will do s.toOwned. All right, get a Rust format to make this all nice and pretty. Okay, so now we've got ourselves some benchmarks. Let's run them. Let's compare a small string. Let's compare creating a string using toString from a small array, a small slice of U8s versus a toOwned call. And they seem to be virtually the same. There is slight differences, but those slight differences are, within the error window. Because this is a really, really quick function, anything going on the CPU might have some sort of impact on the test. So because we want to get rid of all these impacts, we can make our benchmark run longer, get more samples of data, take more time to warm up to get the CPU and the caches warm. We can add that sort of stuff here into our benchmarking stuff by doing things with the group. So what you can do with the group is say you want to do a warm-up time of adding, say, a warm-up time of 10 seconds. And what you also want to do is you want to do a measurement time, let it run for a total of, say, let's let it run for 15 seconds. And let's also grab some sample data of the billions or millions of iterations run. This will grab like samples of those because it's not going to time each and every one of these things. It needs to pick samples of all that data. So let's do a sample size. And normally the sample size is 100, but let's do a 1,000 samples. And this should hopefully eliminate some of the this should get our data more normalized. So let's give this a run, and it'll take 30, 40, 50 seconds to run. So as you can see, the numbers are basically equal here. We've done our best, the best that we can to kind of normalize the data here, but because this test is so incredibly fast, anything happening on the CPU, anything that might interrupt the process from running will have, like, even tiny things will have an impact on this test. What we care about is basically, are these two generally the same? And yes, they are generally the same. But that's kind of so we've answered the question: should you use two-string or two-owned for very small things? But very small things, they don't really matter, because like even if one of these took 8 nanoseconds and the other took 13, that's such a small amount of time that a difference wouldn't really matter, even though the percentage of those is pretty large. What about larger arrays of strings? Let's write a benchmark to test something at a full memory page worth of data here. So we're going to test to see how long this takes, what the difference is on 4096 bytes of data. So we can start that test off by just copying what we used to have here and pasting that and changing some of the names here. So instead of 16, we'll call it 4096. We will change the len to 4096, and we will change the name to 4096. Then we will add this test into the group. And I don't want to run this test this time because we've already ran it, and we just want to test the bigger one right now. So let's give that test a run. So again, we are pretty close. And if I ran this over and over again, these numbers would jump around a little bit. They're basically within the same kind of noise tolerance of each other. 62 nanoseconds versus 57 isn't all that different. It is, in fact, 62.47 divided by 57.96. It's 7% slower. However, things might have been running during the two-owned run because this is supposed to be so fast. Yeah, I have OBS running. I have all my editors running and stuff like that. I've got Open Office Impress. I have Firefox running. There's lots of stuff happening on this machine that might impact these tests, and these tests are so fast that any small thing will impact the test. What we care about is that they are the same. If I ran this again, they'd be closer together probably. So yeah, the next test that we want to create is not just testing normal strings, but testing those UTF-8 strings. So let's write up the tests for those. Because maybe two owned is faster with real UTF-8, not just ASCII strings. So let's grab this, and we will create ourselves a test UTF-8 4096, and this character, I will have to go grab it. We will change it to that. And yeah, might as well keep it at 4096. And this will be called UTF-8 4096. And we will add test UTF-8 4096 to our group. And let's run the test. Now you should have noticed something. That didn't take as long as I expected it to take. One of the problems that I've seen with Criterion is that if you don't give it enough time to capture the samples that it needs, sometimes it just seems to return early. And sometimes when it returns early, that data that it gives you isn't accurate. So what we want to do here is, because our test UTF-8 4096 is actually using 4096 times 3 amount of bytes, because that's the size of the UTF-8 character that you can't see because NeoVim isn't displaying it properly. But that character is actually 3 bytes long. So we've actually got a pretty large amount of data here. And we're not giving ourselves the required time to be able to fully run this test. So let's up that to 30 seconds. And let's run the test again. And this should take 1 minute 20 seconds to run, not just 15 seconds or so. That was still too fast. So let's up it again to, actually let's lower the size. Let's keep ourselves at 30 seconds, but lower the size of this to, what is 4096 divided by 3? 4096 divided by 3 is 1365, so we'll put 1364. 1364. All right. Now this is a little jarring. This is a pretty large difference here. Again, it's yeah. I don't think we have captured enough samples for this. Let's run it for 45 seconds and capture 2,000 samples. All right, these numbers look a little bit more reasonable here. So again, you can see that basically 2 owned and 2 string is exactly the same speed as each other. So that should give you a pretty good introduction to Criterion here. It's pretty easy to use. You just add in your Criterion to your dev dependencies. You create yourself a benchmark. In your benchmark, you just create a function, and that function will use this bench function from the benchmarking group, and yeah, you can do some stuff with it and benchmark your functions. The last thing that we want to do is, because if we were going to add this as a normal part of our development procedure, we would fully enable all these tests. Now this will take quite a while to run, so I don't want to run it again, but now all of them are part of this benchmarking suite that you can run whenever you make a change to your code and see if you've impacted the performance on it. See if you get, a big old change inside of your benchmarks here, assuming that your benchmarks are not as um, specifically benchmarking this one function, and this one function is exceptionally highly optimized. That's why we see so much derivation and so much noise in the data here. Your functions will often take longer than a single toString call, because toString is part of your function, and your function does other stuff with the string data and stuff like that. So your function should take longer than this standard library call. But anyways, so yeah, that gives you a good overview of Criterion. But back to the matter at hand. As you see, they're equal. But of course they're equal. They're the exact same code. So let me show you kind of how we could have gone through this in a more fast way, I guess. ToOwned is implemented by a trait called ToOwned, and it's specifically made. There's a specific implementation for stir, and what it does is it uses that from UTF-8 unchecked value on an array of bytes. And what happens with the toString is specific for stir, and toString makes a string : from. The string : from is implemented for a reference stir, and what it does is it just does ToOwned. So they both boil down to just this one call of from UTF-8 unchecked. The compiler will know, it will be able to optimize the various stages that the toString goes to become ToOwned. So they are exactly the same code. So this whole idea of ToOwned being faster than toString is no longer true, because toString is ToOwned. So why do we have both of these now? Well, it's historic. People used ToOwned in the past because it was faster, and we don't want the standard library to change and break those old programs that are using ToOwned. ToOwned and toString also have different semantic meanings. So that gets us into what is idiomatic. What do semantics mean? Semantics are the meanings of words, and idiomatic is the natural speech that we use. So the dictionary term for idiomatic is using, containing, or denoting expressions that are natural to a native speaker, such as the phrase distinctive idiomatic dialogue. Now, it's ironic that they use this phrase distinctive idiomatic dialogue because a native English speaker doesn't use the term idiomatic. So that's a little bit ironic, but like they have to use the word in a sentence because that's what dictionaries have to do. But yeah, idiomatic means common parlance, the normal turns of phrases, the way people speak. That's what idiomatic means. Now, the semantics of toString and ToOwn differ. ToString means I want to make a string. The toString trait makes a string. The ToOwned trait is for turning a borrowed thing into an owned thing. So they do mean different things here. ToOwned is more about taking a borrowed thing and giving yourself ownership of a copy of that thing, while string is about making a string. So there are kind of two arguments about idiomatic. The idiomatic use of ToOwned is because ToOwned is now a common turn of phrase. It's been used so often for so many years that ToOwned is common parlance. It is how Rustaceans speak. But there is another part of the idiomatic idea that you should say what you mean. And to say what you mean is, if you want a string, you should say to string. If you don't care about the result being a string, what you care about is obtaining ownership over the refster, you should say to owned. So yeah, I hope that kind of solves some of the lingering questions people might have had. Should you use toString? Should you use toOwned? Well, you should say what you mean, unless you exist in a work culture where your peers and your contemporaries have used toOwned for so long that that is the common turn of phrase. Or you actually don't care that you have a string. What you care about is ownership of that borrowed refster. If what you care about is ownership, use toOwned. And I hope that I've shown you how to use Criterion to be able to kind of answer some questions that you might have had. What is faster? Is toOwned faster? Is toString faster? They're exactly the same. Of course, they're exactly the same. They are the same code. So yeah, thank you very much. Thank you for watching. I hope you have a good day, a good evening, or a good afternoon.